Hello viewers, today we have 3D printing filament from TinkerX, which was sent to us directly by the brand. TinkerX is an India-based company located in Nashik, and today we will be taking a close look at their PLA Plus filament. We have two colors here, orange and navy blue, both in PLA Plus. Starting with the filament box quality, the box feels sturdy and provides good damage resistance during shipping, which is especially important for filament ordered online. TinkerX uses a pizza box style opening, which makes it easy to open, access the filament, and even reuse the box for storage. Inside the box, the filament comes in a properly vacuum sealed bag with a tight wrap around the spool. There are no visible air leaks, which is a very good sign, especially for PLA+. The silica gel is present in good quantity and appears fresh, which helps protect the filament from moisture during storage and shipping. Now let's check the filament winding quality, which is often overlooked but extremely important. The winding looks uniform with no visible crossover or loose loops, which reduces the risk of tangles during long prints. Now checking the compatibility with AMS system and regular spool holders. The spool rotates freely and fits well without scraping, which means it should work smoothly with AMS roller and standard holders. Finally, let's talk about color accuracy. Comparing the actual filament with the product images online, the colors are very close, with good pigment consistency and no visible dullness. In the next section, we will print real-world models and test strength, surface finish and consistency. So let's get printing. All the models are printed using default PLA settings, no tuning, so this reflects a true out-of-the-box experience. We start with the classic Benchy, printed on two very different machines, a high-speed P1S and a budget-friendly Kobra Neo 2. Benchy still matters because it instantly reveals cooling performance, overhang quality, layer consistency and bridging behavior. Both benches show clean overhangs and smooth layers. Bridging is controlled and cooling holds up well on both machines, which is a strong start. Next is a mesh notes box designed to stress, retraction and travel moves. This model exaggerates stringing issues if the filament isn't well behaved. As we can see, stringing is minimal and doesn't require any manual cleanup, which means default retraction settings works well here. This is a print-in-place gear fidget spinner, mainly testing tolerance accuracy. The goal is smooth movement without any post-processing. The gears move freely without forcing. This confirms accurate tolerances and consistent extrusion. Our next print is a vase, making it perfect for evaluating surface finish and cooling stability. The surface finish is smooth and consistent, with a balanced semi-matte look and no visible layer line fluctuations. Next up is hoodie pen holder that may look simple but it's underrated. It tests thin walls, flexibility and real-world functional stress. Both colors and machines deliver solid strength. Walls don't feel brittle and it performs well for everyday desk use. The Prusa MK4S rocket engine model runs for a longer duration and includes complex curves and overhangs, making it ideal for testing long print stability and layer adhesion. After completion, we can see the layers remain well bonded and the color pops nicely on curved surface without any visible banding. This result gives confidence that the filament can handle long prints with complex geometry without degradation in quality. Our final and most demanding test is a multi-part walking robot. This checks part-to-part consistency, joint strength and long-term mechanical tolerance. We can see the dimensional consistency remains stable across all parts. Assembly of the robot is smooth, the joints move freely without excessive looseness and the robot walks reliably. After running multiple prints across different machines and use cases, let's wrap this up with a clear and honest conclusion. Starting with color consistency, across all prints and across both machines, the color remains consistent. There is no visible shade shift between prints, and layer to layer color uniformity is well maintained. During testing, there were no mid-print extruder jams on either the Bambu Lab P1S or the Anycubic Kobra Neo 2. This suggests stable filament diameter and no moisture related extrusion issues during the print. There were no filament tangles or snagging during any of the prints. The filament unwound smoothly, indicating good factory binding rather than relying on user correction. Bed adhesion was also reliable throughout the testing. No glue or brims were required, and all models printed successfully using default bed settings. One of the biggest positives here is how beginner friendly this filament is. It worked well on the Bambu Lab default PLA profile and the Anycubic stock PLA profile without any tuning. That makes it a good choice for beginners who just want reliable results. Overall, this filament delivers consistent color, reliable extrusion and stress-free long prints, even with complex geometry. If you are looking for a PLA Plus that works well straight out of the box, this one is definitely worth considering, as it is truly a filament which prints without any limit.